A number of years ago I had the opportunity to work on what's called the Everglades restoration system, and the Florida Everglades restoration project actually. And we had a series of numerical models that looked at the surface water and groundwater flow throughout Florida, but in particular flow into the Everglades, which of course is this region in southern Florida. Lake Okeechobee is a big part of the natural system of groundwater and surface water flow down into the Everglades. And so for any numerical model, you need to discretize the region into points, and you have input on those points. And so I'm going to show you what an example of the data used for simulating flow out of Lake Okeechobee into the Everglades looked like. In fact, this was there's a series of rain gauges in southern Florida where they have long-term records of rainfall dating back into the late 1800s, and the series of rain gauges are used to interpolate rainfall over the area of Lake Okeechobee. And so I have a data file from back a few years ago in which there are 175 or so points discretized in rows and columns across this lake, and then rainfall is interpolated on all of those points. And so I'm going to hop over into Excel to show you what that looks like. The grid for Lake Okeechobee looks like this. Of course, it's probably rotated 90 degrees compared to the map that we were just looking at. But nonetheless, these are rows and columns of discretized points, and at each of these points there's an easting and a northing coordinate that corresponds to each of these points. And looking at the data, this is sort of a compressed file format where you have a row, comma, column, location, and then the interpolated value of rain on the day of January 1st, 1895, January 1st, 1895, and January 2nd, 1895, and you can see that each day those numbers change. And in fact, as you scan across this data row here, you can see that even though in column 6640 there was 0.27 inches of rain, and 5841 there was 0, and that has to do with the spatial distribution of rain across southern Florida and the way that whoever did the discretization and interpolation of rainfall onto the discretized grids, however they did it. But nonetheless, out here in column FV, which is pretty far out there, you have an average rainfall of 0.13 inches on that day on January 1st, 1895, and you can see how the average changes over time as we work down. This entire file itself starts in January 1st, 1895, goes all the way down to December 31st, 1993. That's 36,000 days of data, 99 years of data. And so I'm going to use the data reshaping tool to take this and convert this type of pivot table type format into a format that Tableau can use. And so I'm going to start with the reshaping tool. And what's interesting about this example is that this is such a large file that when I begin the reshaping tool, it says this exceeds the size. For Excel, there's over 6,000 rows of data. Output will be sent to a CSV file, which I think is really great. So there it goes. It's starting the process of writing the data to that CSV file. And once I get the data into the CSV file, what I'm going to do is I'll relate these row and column labels here to the actual coordinates on the map, and then I'll do lookups on those coordinates, fill in the data set. I'll probably use Tableau just to blend the location data to those labels, and then we'll plot it in Tableau and do an animation of rainfall over time over the surface of Lake Okeechobee. And I think we'll do some visual analytics of that to have a look at Tableau's power of handling such a large data set. So for now, I'm going to pause the cap. So now we've created the CSV file. We'll edit that, have a look at it. So we have month, day, year, a blank column, the location, row, comma, column, and then the value of the rainfall. So I'll take this file, work it up a little bit, get rid of basically I'll create a complete date from these fields, and then I'll change the column headings and a few other things to get this into Tableau. You can see that this is 6.3 million lines of data now, and that's what I'll use to put into Tableau, and I'll blend it again with the location information that's in this table here. So I'll take this location lookup and pull out the easting and northing coordinates for Lake Okeechobee, and then we'll create it. There'll be a distribution like this of daily data of rainfall across all of these points, and we'll see what we can do with that in Tableau.